Hi everyone. For this question, it says express the fraction in the form of partial fractions. Hence, evaluate this integral from 1 to exponential. Then give your answer correct to three significant figures. First, we answer for the first part here. Express this fraction in partial fraction. So partial fraction step number one will be identify it is proper or improper. So up here is a cubic function. Then x squared times x squared, here it will be quadratic function. So x to the power of 4, this is x to the power of 3. So numerator power is less than denominator power. So this fraction is already proper. Then second step will be make sure the denominator here factorize completely. So for x squared means it will be x times x. This x squared plus 1 quadratic cannot factorize anymore. Then for the third step, we continue here. We are going to split according the factor. So according the denominator here, we have one repeating factor about the factor of x and one quadratic factor. For repeating factor, we will start with x, and then another one is repeat factor for twice x squared. Then another factor we have is quadratic factor. So this is step number 3, split according the factor. Step number 4, we need to identify what is the numerator up here. When this is a linear factor, up here need to be constant. So this is not a quadratic, this is just repeating factor for x. Repeating factor for x still consider is a linear. So up here you need a constant. Then for the another factor, this one is quadratic factor. So quadratic factor up here need to be defined as linear. Then step number 5, we're going to equate the denominator so that we can get one equation for us ready to find out this A, B, C, D. So A, we're going to times the factor you don't have, which is one more factor x and x squared plus 1. Meanwhile for B, we're going to time with x squared plus 1. Then cx plus d, remember put in bracket because together you need to time with the factor you don't have, which is x squared. Then step number 6 is going to let or compare to find out the unknown a, b, c, d. So if we can find a nice value, which is the x from the roots, which is 0, we try to let first. So let x equals to 0. And we can notice that A, B, C, D, 4 unknown. You need to let it 4 times. But we only have a nice value roots number, which is x equals to 0 only. Therefore, we need to mix it. Firstly, we start with let. Then after that, we do comparison. So when x equals to 0, substitute, you get negative 1. So this one becomes 0. This one becomes 1b. Then this is 0. So we get the first unknown where b equals to negative 1. Then the rest of it, we still have 3 unknown, which is a, c, d haven't find. So if we continue using let, we are getting 3 simultaneous equations. So to avoid that, we will change our method to comparison. So to do comparison, we need to expand out. So for this a, we're going to expand out. It will be ax cubed plus ax. B we already know, so we put in the value negative x squared, negative 1. Then this one we expand will be cx cubed, and then this is dx squared. So we collect back the x cubed term, it will be a plus c for x cubed. For x squared term will be negative 1 and d plus dx squared. Linear only have ax, constant is negative 1. When we compare, so a plus c suppose equals to 5. For square term, 1, negative 1 plus d suppose equals to negative 1. And then a have to become coefficient 1. Then lastly constant is negative 1. So from this comparison, we come up this result. And we managed to find our value of a. So once we find our value of a, we can substitute a equals to 1. C will be 5 minus 1, which is 4. Then we find the value of c. Then this one d, we can simplify. It will become 0. So lastly, step number 6, finding a, b, c, d, done. Then for the last step, we're going to substitute back inside this partial fraction. A over x, b over x squared, cx plus d, d is 0 over x squared plus 1. So substitute back here. Here we done for the first part of expressing this fraction in partial fraction. Then we need to evaluate this integral from 1 to e and give the answer to 3 significant figures. So which means that we're going to integrate 1 until e for 1 over x minus 1 over x squared plus 4x over x squared plus 1 dx. So look at our integration here, all in fraction form. So is it necessary to put it in fraction? When we have denominator power of 1, yes, we integrate in fraction form, so the formula number 6. But if your denominator is not power 1, this power should be rewritable to be the formula number 2, individual x. And this is fraction form. You can see power only 1, so we can see, we check here, it has special form. So the formula we need here is about number 6. Integrate 1 over x, you get ln x plus c. Another special form is integrate fx f prime x it will ln fx plus c. So we test here, the denominator function is x squared plus 1. When we differentiate it, it's supposed to get 2x. So here we can multiply, we factorize 2, so we can get denominator is fx, numerator is f prime x. So when we have this special form of integrate, we can use formula straight away. It can give us ln to the denominator function. So we rewrite this, where x squared supposed to be rewrite into the power form, and the 2 here we factorize out so that we can get the pattern that we want. Then when we integrate this, it will be ln modulus x minus power plus 1 over new power, and then this one ln to the function. Upper limit e, lower limit 1. Then what we need to do is we substitute upper limit minus lower limit of 1. Negative, negative, positive. Substitute 1, ln 1, 0. Negative, negative, positive, 1 over 1. plus 2 ln 2. So evaluate this using calculator and we round off to 3 significant as the question asks here. So our calculator can give us 3.235. So 35 we need to round off become 24. And this is our final answer in 3 significant figure as stated from the questions here. So that's all for this.